Hello, I welcome you all to this session. Today we will be discussing about the graphs. Uh, so let's begin. We will discuss mostly the graphs of commonly used functions. So, and this will help you to solve the problem of equations. So if the problem is that you have to find out the number of equation, the number of solutions of a given equation, then the plotting of this graph will definitely help you. So let's begin. So first of all, I these functions we will be discussing. Okay. E to the power x, then log x to the base c, then these are the graphs of sin x, cos x, tan x. Once we are done with these things, we'll start y equal to, so these are basically y equal to fx. Now, once we are done with y equal to fx, we will start with y equal to f of mod x, then y equal to mod f of x. So once we know what is the graph of the fx, then we will be discussing about this y equal to f of mod x, then y equal to mod f of x, and then mod y equal to mod f of x. So we will discuss the possible combinations. So let's go to the first graph, which is y equal to e to the power x. So as we know, this e to the power x is a is an increasing function, continuously increasing function, monotonically increasing function. It will increase throughout its domain. So it's the domain is basically minus infinity to infinity. The domain is minus infinity to infinity, and range is basically if you put it's a monotonically continuous function, so you will get the monotonically increasing function, so you will get the uh, minima at minus infinity. So if you put e to the power minus infinity, then it is approaching zero, and as it is monotonically increasing, you will get the maxima at infinity. So so putting infinity in place of x, it will lead to infinity. So and if we keep x equal to 0, then we will get that y equal to 1. Can fix this point. It's 0 1. So okay, let's just erase this. writing this 0 1 here. So now the graph will be like this. Now it's monotonically increasing. This is my 0 1 point, and this is x-axis, this is y-axis. So x, y. Now if you are given a problem at e to the power x equal to minus x, then how will you solve it? So, and you will be asked that how many solutions, how many real solutions of x is possible. So then in that case, you will find out, basically you will plot the graph of this y equal to e to the power x and y equal to minus x. These two graphs separately you will draw, but in a single plot. Okay, so e to the power x graph is this one, but y equal to it minus x, this is this graph, this straight line, so which is basically passing through this origin 0 0. So we can see that they are basically intersecting at one point only. So this point, although you cannot find through this method, but you will obviously get to know how many points are intersecting these two plots. So from there you will know how many real solution is possible. Okay, so going to our uh, next graph. So one graph can be like that. You can be given this one, y equal to e to the power minus x. Okay, yeah. So you, like, this is like you are given y equal to fx. You are given y equal to fx. You have to find out y equal to f of minus x. So in that case, what you will do? See, this is the graph y equal to e to the power x. So to find out this y equal to f of minus x, you have to imagine this y-axis as a mirror, and then you will take the reflection of this y equal to fx in that mirror. Then what will happen? You will get y equal to f of minus x. So this thing you have to do. So you will, so if this is y equal to e to the power minus x, e to the power x, sorry, then it is e to the power minus x, and I can prove it like the range. So this is also a monotonic function, but it is monotonically decreasing. So if it is monotonically decreasing, then I will find the global maxima at minus infinity, and obviously the range is the domain is minus infinity to infinity. So so the domain is minus infinity to infinity, so I will get the maxima at minus infinity. So if you put e to the power minus x and Sorry. So if you put e to the power minus x equal to minus infinity here in e to the power minus x, then it will become e to the power infinity, which is infinity, which will approach to infinity. So we can see that it will start from infinity and will, like, the value will reduce down to 0 at x equal to infinity. So this is the plot of e to the power minus x. Then it will be given like log x, this, let me see. So one property of log x is that it never takes x negative x value. So, and also 0. So it always takes non-negative x value. So the domain is x equal to non-negative. This is the domain of the function is, domain is non-negative x, you can say. And the graph will be like, so at x equal to 1, this is y equal to ln x or log x to the base e. So at x equal to 1, y will be equal to 0. So this 1 0 point, this will be a point on the plot. So this will be like that. Okay, because at x equal to 0, this y will approach to minus infinity, and at x equal to infinity, y will approach to infinity. So it will be monotonically increasing graph, but the point is like, one thing I will say about it, that the rate of this increment will go down. So this is x and this is y. So basically this log x is an increasing function, but the rate of increment is decreasing. Here what is the rate of increment? Here the rate of increment is less. So if the curve is, as you can see, the tangent here is like that. Here the tangent is like that. The slope is very high. Here you can see the slope is less. Here more less. So basically the rate of increment is decreasing. So next we have the graph y equal to sin x. So it's a periodic function. So domain of x, domain is 0 to 2 pi. 0, basically not 0 to 2 pi. Domain is infinite, minus infinity to infinity, minus infinity to infinity. But it will repeat after completing a it will repeat after completing a period from 0 to 2 pi. So it will repeat after that. Here also. So at pi, at the multiples of pi, the value of the function is 0, and at the odd multiples of pi by 2, the value is either, so sorry, this is pi by 2 and this is 1. So at the odd multiples of pi by 2, the value of the function is either 1 or minus 1. Here you can see this is 3 pi by 2, and the value of the function is minus 1. Okay, so this is the graph of y equal to sin x. Next we come to y equal to cos x. This is also similar kind of function. Here also it's periodic and periodicity is 2 pi. And the domain is obviously minus infinity to infinity, and the range is minus 1 to 1. But we will see how is the curve. So unlike sin x, for cos x at x equal to 0, it is getting a maxima. So at x equal to 0, the value of the function is 1. Then at pi by 2, it is getting, at pi by 2 it is getting the value of 0. Then again at 2 pi it is becoming 1. So that's the case. Then again it will repeat after 2 pi. So this is 1, this is minus 1. Okay, and this is 0, this is pi by 2, this is pi. At pi, value of y equal to, at x equal to pi, value of y equal to minus 1. So this is the case. Basically this is minus 1. This is y equal to cos x. Next we will go to y equal to tan x. So tan x is something different from sin x and cos x. Okay, so it shows different behavior. Basically, see at so for cos x and sin x, you can see one thing. You notice one thing: the graph does not break anywhere. So it's a continuous graph. For sin x also you can see the graph is continuous. But in case of tan x you will see that so it will increase its value at minus pi by 2. And the value of y will be minus infinity. But at pi by 2 the value of y will be plus infinity. So you can see this is the curve. This is the curve. This is 0. This is minus pi by 2. This is pi by 2. Okay, and then this curve, then this thing will repeat. Okay, so this might be pi. This is 3 pi by 2, and this thing will repeat. This thing will repeat. Here also it will repeat. But you can see that the graph is breaking at this odd multiples of pi by 2. The graph is breaking, so it's not continuous. So this is the speciality of like exceptional behavior of tan x from sin x and cos x. And also one thing like its the range is from minus infinity to plus infinity, unlike sin x and cos x where the range is from minus 1 to plus 1. But the domain is in everywhere. The domain is from minus infinity to plus infinity. So that's the case. Next, what we told we will be discussing. Yeah. So next we will be discussing on this once you are given y equal to fx. So you are given y equal to fx. So in that case, you have to find y equal to f of mod x. Okay. So something given and you have to find something. This one you have to find. So let's see how can we tackle it. Suppose this is your y equal to fx curve. So how can we, once we are given this y equal to fx, so how can we plot y equal to f of mod x? So the rules are like first I would say remove I would say remove this part. Okay, so you have to remove this part. Remove whatever is there before x equal to 0. So you will start from minus infinity or start from the domain of uh, this curve. So once you reach and you will increase the value of x. Once you reach x equal to 0, then you will start removing whatever is there before x equal to 0 or the left part of this y-axis, whatever is in the left part of y-axis, that portion you can remove. So you can remove this portion. So you will remove this portion. Sorry, this y-axis was also removed. So now what will you do? You will consider y-axis as a mirror and you will take, so you will consider y-axis as a mirror and then take the image of this portion. Take the image whatever is in the right of this y-axis. Then take the image of, so we can say that it is y equal to fx where x greater than 0. With respect to y-axis. So with respect to y-axis, you will take the image of this. So this will be like this, then this, then this, then this sort of, then like this, then something like this. So if it were a regular curve like sin x, then it would be like this. So this is what you have to do. So let's take an example. Yeah, let's say y equal to e to the power x. This is given. So you already know what is y equal to e to the power x. What is the, like, how is the y equal to e to the power x curve. So you will draw. Then you will be asked to find out y equal to e to the power mod x. So in that case, what you will do, you will remove whatever is in the left portion of y-axis, and you will take a print. You will image of take an image of this. So this is our y equal to e to the power mod x. This curve is y equal to e to the power mod x. So this is my x-axis and this is the y-axis. Now you will be asked, you will be given a function y equal to fx, and you will be asked to find out y equal to mod f of x. So how you can find this out? Like how can you find out? So in that case, what you will do? So let's see. Suppose this is a function. This is a function y equal to fx. This function. So you have to find out y equal to mod f of x. So see one thing, that mod f of x denotes that if y equal to mod f of x, then it denotes that y is always positive. Whatever be the value of x, y will be always positive because this fx is under mod. So here y is negative in that portion and y is positive in that portion. So you will do one thing. So you will, what you will do, so until you are getting fx to be positive, so once you get this fx equal to positive, you will keep rest of the graph as it is. But before that, wherever this y equal to fx is negative, you have to make it positive. So for that, what you will do, you will take an image of that portion with respect to this x-axis. So if I do this operation, how will it be? So this is the curve. So what I will do, see, I will cut this portion. This portion I will keep because here fx is positive or y is positive, but here y is not positive. So I will cut this portion and take an image of this portion with respect to this x-axis. So how will it be? So this is like this. The image will be like this. So so if we combine this and this image and the leftover which was not cut, so then we'll get that this is the basically our y equal to fx. So I will write some rule how we can get it. So if y greater than 0, keep it as it is. If y less than 0, take an image of this portion with respect to x-axis. Okay, so now let's take an example. Suppose this example is y equal to ln ln x. So we all know what is the like how is the graph ln x graph we all know. So this is like that. So if you are asked to find out the mod ln x graph y equal to mod ln x, then what you will do? First thing first, you will keep this positive where y equal to 0, you will keep this thing as it was. So you will keep this thing as it was. This is basically 10 point. So from 10, you will keep as it was. So and in the left side of 10, whatever you were having, so you will take an image of that portion with respect to x-axis. So if I take an image of this portion with respect to x-axis, then how will it look? It will look something like this. It will look like this. So this is my y equal to ln x.